Welcome to the Lost Debate, a show for political eclectics. I'm Ravi Gupta, and today I'm talking to Dr. Tommy Wood all about age-related cognitive decline and how to avoid it. And I'll talk in a second about who he is. But before we get there, as a reminder, my novel is coming out next Tuesday, March 25th. The book is called Garbage Town, and it's a coming-of-age thriller about a group of kids growing up in Staten Island, New York in the 90s in the shadows of the Fresh Kills landfill. And you can pre-order it wherever you get your books. And if you're around, I'm doing a bunch of book events. So one on March 27th in the Lower East Side of Manhattan, one on March 30th in Staten Island, and one on March 31st with Jason Kander in St. Louis. And we'll link in the show notes to where you can sign up for those events. Each one of those, you need to get a ticket. In most cases, they're either free or just a couple of dollars. And if you come to those events, I'll sign your book for you. And either way, no matter where you are, get a copy of it. And I'll be talking probably more about it in the next couple episodes, and probably have a special episode where I talk about the novel. But the reason why you're here today is I'm talking to Tommy Wood, and he is an assistant professor of pediatrics and neuroscience at the University of Washington. He is somebody who has worked with athletes, including Formula One drivers, and he basically helps them improve their cognitive performance. He's also a trustee and director at the British Society for Lifestyle Medicine. He has a very popular podcast that we'll link to in the show notes, all about your brain and cognitive performance. And what we talk about mostly is age-related cognitive decline and what we can do to either slow or reverse that process. Slow, stop, reverse is how I try to think about it. And he gives us advice from everything from sleep to sports to exercise to nutrition to socialization. Basically, what are the things that we can do to help avoid degeneration? And so this is a very practical episode. I think you're going to find a lot of lessons here. Let's jump in. Tommy, welcome to the podcast.
Thanks so much for having me. It's great to be here.
Well, there are a lot of things we could talk about, but I would love to spend the bulk of our time on cognitive decline, which is something I know that's very much on our audience's minds. And particularly, let's try to focus as much as possible on age-related cognitive decline. And perhaps we can have some time for the so-called pathological decline, things like Alzheimer's. But I would love to just get your sense of, I'm working on this book right now with some people that over at Harmony. And one of the major areas of research that I've been diving into is the area of the subcategories of cognition and how those either get worse or better as life goes on. And there are I've probably found like 20 books that all regurgitate the same science around fluid, crystallized intelligence, yada, yada, yada. And in looking at some of the interviews that you've done and the research that you've done and explored, it seems like you have a slightly different set of sort of categories that you draw from, and you're probably a lot more pessimistic, I would say, on this subject than a lot of people. So maybe let's start there. At a basic level, do we get worse? Does our cognition get worse with time, and what parts of our cognition get worse with time?
First, I'm going to ask you a question back. I am incredibly optimistic about our trajectory or potential for trajectories of cognitive function across the lifespan. So I'm wondering what it was that you saw that made you think that I'm pessimistic.
I think it was the interview you did with Atia, where it was like, basically like the way that you guys got into it was, he was like, you were basically like, everything gets worse except for what you call historical cognition, if I'm remembering this correctly. And that was, I would say, like slightly less positive, because when I'm reading other people's science or other people's descriptions of science, like in Arthur Brooks, for example, I feel like people go out of their way to say, well, there's this thing called crystallized intelligence, which I feel like is a slightly larger category than the category that you're using. I'm probably getting too like in the weeds early here, but does that make sense? That's where. Now, when you talk about solutions, I think you're very optimistic. Like, what can you do? Like, I've been keeping a running list as I go through your work, which I was going to save for the end, of like all the things we can do to fight this process. But do I have that wrong? That's probably a good place to start.
Sure. So I think when I was giving those examples, I was mainly talking about how we think in general in the scientific literature, the different functions or parts of cognition change over the lifespan. I don't think that has to be the case, and I'm happy to tell you why that is. But sort of the broad categories that you mention, one is crystallized intelligence, so this does seem, if you look at the standard graph you'll see in a paper, which has the different parts of cognitive function and how they change across the lifespan, say from age 30 to 90. Crystallized intelligence kind of may even increase into the 50s and 60s and sort of stays stable. That includes parts of emotional regulation. It includes autobiographical memory, so things we remember about ourselves. It includes semantic memory, so just like knowledge about the world around us. And it also includes sort of some memory of the skills and habits that we have, automatic memory, so things that just sort of like we don't try and remember, our brain just remembers them. And these kind of come together partly in this idea of wisdom, right? We get better at drawing things together, making sort of like a reasoned decision about something because of all this knowledge that we've accumulated. That all sort of folds into crystallized intelligence, and it sort of increases as we get older into our 50s and 60s, and then sort of stays stable-ish or doesn't generally drop too much on average. And I was listening to your podcast with Richard Reeves about we were talking about averages.
Yes,
right?
You're doing
Boys
what I was doing.
Boys on average do this, girls on average do this, and that's important. But the problem is, actually, averages are kind of what get us in a bit of trouble in this area, and we can get into that. So then the other part that you mentioned is fluid intelligence. So this is more things related to like very short-term memory or working memory, reasoning, other aspects of executive function like inhibition. So not doing something when you shouldn't do something, and kind of switching attention. Those seem to be the functions that we think drop the most as we get older. So the reason why I don't think that's necessarily true, and why there isn't necessarily this big separation between those two things, is because of this effect of averages. So one of the studies that shows this the best is the Seattle Longitudinal Study, which was started in Seattle at the University of Washington by Warner Shai in 1956. And what he did was he took people and brought them back every 7 years. And he had a whole bunch of cognitive function tests, including word finding, reasoning, different parts of processing speed. So kind of covering the full gamut of cognitive functions, including crystallized intelligence and fluid intelligence. And what he found was that the average does decrease with age. So you look at people as they get into their 60s, 70s, and 80s, the average does decrease. And that's because there's some group of individuals who are getting worse over time. But even with reasoning, which is a part of fluid intelligence, about 50% of people stayed stable in terms of their reasoning ability into their 80s. So it's not that it decreases over time for everybody. It's that some people decrease and that pulls the average down. And what we see when we see these graphs is that the average decreases over time. So there's this kind of idea that these different functions decrease of cognitive function decreases as we get older, but actually there are very different population effects. And for most people, they can stay stable as we get into our 80s. And actually, that research was part of what was used to increase the retirement age in the 80s, because people started to realize that we weren't like William Osler suggested, that once we hit 60, we're essentially useless and we should be turfed out the back and put out to pasture. Actually, we can maintain cognitive function into late into life. And so that's why I'm actually quite positive about this field, because I think we can retain more cognitive function than some people might say we can.
So, well, that's great news. For the folks who are beating the average, what do we know about what they do?
There's a few different things that we can look at. So if we go back to those same data from the Seattle longitudinal study, there were some kind of common threads that popped out over dozens of papers that they published from the study. They were one of the first studies to show that cardiovascular disease and high blood pressure are risk factors for cognitive decline. When we know this is a big part of Alzheimer's disease and other dementia risk factors, but they were one of the first groups to show that. So anything that decreases your cardiovascular risk, and that can be related to sleep, physical activity, diet, managing cholesterol and diabetes and all those other kinds of things. But something else that they really focused on was what they called complexity of the environment, which is how engaged your brain is in various different activities that can then train and use those functions. So if you look at other studies where there are a group of individuals that we call super agers, which I don't think is that it makes them sound like they're superheroes, and it might be relatively uncommon, but I don't think that's necessarily true. But anyway, so a super ager is somebody who maintains cognitive function of their 50s into their 80s, and those people tend to be very similar. They're very physically active, they're very cognitively engaged, they do cognitively difficult tasks, and they maintain their overall physical health much better than, again, the average population. So those are all sort of the common threads across people who seem to maintain cognitive function into their sort of 8th, 9th, 10th decades.
Well, what's fascinating, obviously, so as you mentioned, there's this overlap between being physically active and improving your cognitive function. Despite that, though, one thing I find interesting is most of the people in my life, if I were to really press them and say, if you had to choose 20 years from now, you're going to be 50% less athletic, or you're going to be 50% less intelligent and cognitively sharp, most people would pick they would say, all right, I want to maintain my cognition, because that's really who I am. Like, if I'm moving a little bit slower, that's not great, but I really want me to be me still. Yet almost nobody I know in the sort of type A striver world is like thinking about cognitive decline the way that they're thinking about physical decline. Everybody's talking about Peter Attia and Andrew Huberman and yada yada, who have things to say about cognition, but I almost never hear people talking about, all right, I need to do a mental marathon. I need to be doing puzzles every day. Is this something that you picked up on?
Yeah. And first of all, I'll say that luckily your choice isn't a real one, and those things aren't mutually exclusive. And in fact, they're very tightly linked. So if you
being physically active improves your cognition.
Absolutely, across multiple different types of physical activity, and different types of physical activity affect different parts of the brain and different cognitive functions. So if you remain physically active, that's going to help you maintain long-term cognitive function. But I think one of the reasons why people focus very much on the physical rather than the cognitive is because we don't really have a language and a measurement system for how to train, engage, and track cognitive function over time. So I train in the gym every day. I compete in amateur strongman for fun. I know how to track what I've done in terms of the physical stimulus I've applied to my body: sets, reps, weights. Even if you're doing cardiovascular exercise on the rowing machine, I know how long, how far, how hard. If we think about the brain, there really isn't a good way to measure how far, how hard, how long you have stimulated your brain for. We can kind of estimate it. That's why people look at the cognitive stimulus you might get from how complex your work is, your social relationships, whether you engage with things like reading and crosswords and other ways that you can kind of use your brain, for want of a better phrase. But we don't have this really good system of documenting the stimulus that we're giving to the brain, and then it makes it harder to figure out, well, what stimulus results in what outcome. So I think we're just kind of right at the beginning of starting to figure some of that out. And it's that difference between, we've had decades of exercise science that allows us to talk about it in that way. and we just don't yet have that in the field of cognitive function. So then it gets a little bit woolly and gray, and people aren't necessarily as willing to kind of dive in and think about ways that we might be able to, structure or introduce those stimuli that could improve cognitive function at the time.
So I think like part of the goal for people, and certainly something I've been thinking about, is how do you integrate any of these practices to improve your cognition, or at least maintain it, into your daily life in a way that is like sustainable, right? Like, like you're probably not going to be doing like multivariable calculus every day, and that, may or may not help. And so this is a good time to probably walk you through this framework I've been using for the past 6 years. And let me just tell you like what I've been doing, and it would be helpful if you just kind of came back to me and you're like, okay, of the things that you've done, these are the things that I think actually are borne out in the science. And these are the ones where you probably have independent reasons to do them, but improving your cognition is probably not, it is not a factor. So every year since I left running schools, I used to be a school principal. I think you probably got that from the Reeves interview. I focus on each year of my life almost like it's a school year. And I try to learn, try to go from beginner to intermediate in something. So first year was powerlifting, and then I competed in a powerlifting competition at the end of the year. Second year was screenwriting, and I wrote a screenplay and tried to get it sold and all that kind of stuff. Third year, I learned surfing and surfed a barrel. Fourth year, I learned tennis and like created a competition at the end of the year where I got my butt kicked by Mickey, who you met earlier, when he's our producer of this show. And then I wrote a novel the year after that. And then I did, and maybe this is one of the more interesting ones for us to parse through, I took the MCAT one year, which is a 7.5-hour test where I had to learn biochemistry, organic chemistry, physics, yada, yada, yada. And train my brain to concentrate for 7.5 hours and take this test. So as you think about those, first of all, like, is this pursuit, this way of taking each year, in any way helpful for improving cognition and learning new things? And two is, of the ones I mentioned, which are most interesting to you from the perspective of improving cognition?
So I understand why you have it structured as a school year, as a former high school principal. I'm not sure that it needs to be structured on a yearly basis, but if that helps you anchor it and give you a goal that then you achieve, then that's great, because the continued engagement in the task is the most important thing.
Yeah, the reason, just to answer that, is the reason why I do it in a year is to avoid like multitasking on the skill. So it's like to be like, all right, I have a defined goal for this year, as opposed to trying like 3 different things, or like letting it, like my goal sort of bleed into the next year. It's like, okay, I got to write. The novel year is a good example. I was like racing at the end of October and November of that year to finish the novel, which is not something I would have done if I didn't have like the year framework. If that makes sense.
Yeah, no, that does make sense. And if you think about some of the basic principles of behavior change, if you try and do lots of things at the same time, you'll do none of them. So it makes perfect sense to structure it in that way. I don't have a favorite of all the things. Like, they all sound fantastic in different ways. And if we think about the same problem that I mentioned earlier, which is that we don't necessarily know how to measure the brain networks that we're engaging in a specific task, I don't know which of those is better than any other of them. And I would guess that the fact that each one in a different way requires the organization and integration of different brain networks suggests that actually the fact that you're doing multiple different tasks or learning different skills is probably going to be better, because you've used your whole brain, like to sort of like really simplify it down. There are some of those that we know a little bit more about than others. For instance, there's a huge body of literature on coordinative exercise, which is probably the type of exercise that has the greatest overall benefit for the brain. Some people would like tennis is a classic example of what we call an open skill sport. It requires you to react to the environment. You have these basic motor skills, but above the sort of the physical component, the cognitive component reactions, task switching, the social aspect, all of those seem to sort of give this additional boost on top of the physical component. So,
and dancing is another example of that, right? Of
is a perfect example.
activities.
Yeah, perhaps the best example. If you look across different studies that have looked at the effects of exercise on mental health, cognitive function, and then also brain structure, you measure the size of the hippocampus in people who do a dance class. Dancing seems to be the activity that has the biggest effect. Doesn't mean you can't say it's statistically significantly better than playing tennis, but if you look at the effect size, the effect size of dancing consistently seems to be one of the biggest.
I've been diving in recently to this research. I think this was probably mentioned on Huberman's podcast, but when he was interviewing David Goggins, which is this research on the anterior mid-cingulate cortex.
Mid-anterior cingulate cortex.
Yeah, and I'm curious, I haven't seen you talk about it publicly, but I'm trying to wrap my head around this concept. It's very Goggins-esque in the sense that it's great if you hate it, basically, which is kind of like, it's kind of a mentally challenging framework, because tennis is a great example. I loved tennis. Like I think Matthew McConaughey said this, where he's like, I almost feel guilty at how much I love doing this thing. It should be harder. Whereas some other things, like writing the novel, it was like going to the dentist every morning. And then when I was like trying to review what literature we had on this part of the brain for the audience, my very Cliff Notes unscientific way of thinking of it is like the less you like it, the more it like grows as part of your brain, which is like the seat of your willpower. And the more that you maintain or grow that part of your brain, the sharper you stay as you get older. Am I roughly getting this right? At least the claim?
You're getting the claim right, and I've certainly looked into this, but for various reasons, I'm not saying that it's not true, and I think the process of doing difficult things is important, but I think it's more important for other reasons that I'll get to. If you look at the mid-anterior cingulate cortex, it sits kind of inside, just behind like the prefrontal cortex at the front of your brain, and it's the size and some of the connectivity within the mid-anterior cingulate cortex seems to be different, in people who, regularly engage in kind of, difficult or challenging tasks. I don't think we know yet, what sort of cause or consequence, or, how much you can, whether you should be actively trying to grow this part of the brain. And I often try and shy away from a focus on specific brain regions, specific neurotransmitters, because in general, when we think about cognitive function, we think about our behavior. These are what we call emergent phenomena, which basically means that if you break down the brain into all its different constituent parts, you can't see what bit of it led you to have this specific action or have this specific skill, or be able to think this specific thing. So because it's so much more complicated than actually anybody really understands, I think it's much easier just to kind of look at inputs and outputs, and then we're kind of like, and then there's like a whole mess of stuff that happens in the middle, and we're kind of trying to figure it out, but we don't really know yet. And so what's interesting about this sort of grind and hustle approach is that, yes, it absolutely works for some people, but it doesn't work for most people. And when you look at some of the literature in terms of what develops true resilience and mental toughness, and that's not the David Goggins description of mental toughness, which is like, I'm just going to suck it up and I'm just going to keep pushing through even though I hate it. Mental toughness is a group of skills that allow you to perform towards the top of your capabilities over long periods of time. And one of the things that boosts mental toughness, and this kind of, some of this literature is done in like youth sports, right? When we're kind of getting the kids set up for life, hopefully, although usually we're just like beating them down again and again and again. But self-compassion is one of the best predictors of mental toughness. And it does that by boosting how good we feel about ourselves. So self-compassion has three main components. One is self-kindness. So that's just if you make mistakes, you treat yourself with respect. You're like, no big deal, like you would with a friend. And it includes common humanity, which is, we're all human. Everybody makes mistakes. It's just like part of life. And then mindfulness is the other part. So when we do things like encourage self-compassion, that is what actually builds mental toughness. It's not having somebody controlling us, telling us you need to do this again and again and again, even though it sucks, you need to push through. If you try and do sports or develop in a controlling environment, you're more likely to develop avoidant stress management strategies. You're more likely to develop sort of like anxious and depressive tendencies in the future. And now I'm going to answer your question, which is that when we do difficult things and we choose to engage in difficult things, what I think they're doing is they're helping to build autonomy and competence, which are two of the main parts of self-determination theory, right? The basic things that humans need to thrive. Autonomy, like having control over our own actions. Competence, feeling like we know what we're doing and we're able to deal with something. And then relatedness, so having, feeling like we're connected to and supported by others. And by choosing to go in my cold tub, which I really don't want to do, but for various reasons it's interesting, I think I'm building some aspects of autonomy and competence. I know that I can make myself do something difficult when I need to, and I know that I'll be able to handle it when that happens. So whether or not that involves the mid-anterior cingulate cortex, I don't actually know, but I also don't necessarily think it matters.
It's interesting what you said is, thinking about Goggins, who talks about looking at himself in the mirror and being like, you're a piece of shit. It's like, it's interesting. Like, I run this fitness community of my friends. There's now like 80 something members of it this year. And the number one thing I remind people of is the people who've been successful in this program are able to bounce back really well. And it gets to what you were saying, like the right balance of kindness. Like, obviously, if you're like 3 weeks in and eating Shake Shack every day and not getting off your couch, like, yes, like kindness is important, but you also need a little tough love. But that's usually not people's problems. Like the people's, generally speaking, spiral. So they're like, they have one bad day and they're like, oh my God, I am a piece of shit and I can't do anything. And then they get depressed and then they don't get off the couch the next day. And that can spiral. So like, I forget who said this, but almost like, one thing I try to remind people is, one of the best things you could say to yourself is, no 2 bad days in a row. Like one bad day, not a big deal, but try not to string together 2 bad days. Because I think it's often the one bad day that screws people up, Yeah.
There's definitely an important balance of challenging and pushing ourselves. Like that, I think, is probably the most important thing if we're whether it's physical or cognitive function across our entire lifespan. But a big part of that involves a belief that we can do it and a belief that it will actually make a difference. So there's this kind of, constant balance of, engaging in something difficult, but also knowing that you can do it. And then sometimes we go too far in the other direction and we just like push, and we never give ourselves a break. So the kind of the way I think about it is that we have to challenge ourselves. It's like, right, if you want bigger biceps, you have to go do bicep curls in the gym. That is the most important thing to build bigger biceps. But your biceps don't grow in the gym. They grow when you're resting afterwards. So we need challenge, we need to push ourselves, but then we need time for adaptation and replenishment so that we can go again. And you can't only have one, you have to have both.
And on that subject, the sort of like replenishment, sleep, like how much does sleep matter here in maintaining strong cognitive capabilities?
It's really important. But by telling people that it's really important, we cause some possible problems. So when you think about neuroplasticity as this, neuroplasticity is this idea that we can continue to, in some parts of the brain make new neurons, but in other parts of the brain make new connections and help to build the structure that supports the neurons in the brain. Neurons, as we think about this as the main sort of cells in the brain that do the communicating, where thoughts are stored and motor actions are initiated. But cells actually make up less than 50% of the cells in the brain. There's a whole mess of other stuff that helps them do. Neurons make up less than 50% of the cells in the brain. There's a whole bunch of other stuff that helps them do that job. But if we think about this process of neuroplasticity, so making new connections as part of skill development, and learning, that happens and is kind of, that process is reset every night when we sleep. So during slow wave sleep or deep sleep, that's when we kind of, and other parts of non-REM sleep, that's kind of where we set our synapses. Like, these are the ones that we made during the day. These are the ones that we're going to keep. These are the ones we don't need anymore. And you kind of reset the system and it's ready to go again the next day. So if you're trying to remember something, learn something, literally do anything with your brain, sleep is really critical. And if you look at long-term cognitive function and risk of dementia, those who are chronically sleeping not enough or have very poor quality sleep and maybe also very irregular sleep, they have an increased risk of dementia. The problem is that now we're so hyper-focused on sleep that we're like stressed about sleep. And there's this continued quest for the perfect night of sleep. And I'll admit that several years ago, I used to be, one of the optimizers. I never called myself a biohacker, but I was like, how do I make this as good as possible? And that could be diet or physical activity or sleep or whatever. The problem is that, like, first of all, we don't necessarily know what perfect is. How much sleep do you need? I don't know. I can guess, but I actually don't know what your perfect night of sleep looks like, and I'm probably never going to be able to measure it. And if you achieve it once, you may never achieve it again. How much does that matter? Probably not that much. But in the pursuit of perfect sleep, what we do is we create this environment where if we don't sleep well, we assume that we're not going to perform well, and as a result, we don't perform well. But it's actually not got anything to do with sleep, because there are several studies that show that, even after a night of total sleep deprivation, your brain will kind of restructure and reorganize itself so that it can keep functioning. Actually, you have huge resilience in the system, but we break down that resilience by the way that we think about it, or with the way we think that there's something that we need.
There was like a study, right, where people were shown data about their sleep and it was irrelevant to how they actually sleep. And if the data they were shown told them they had bad sleep, they would perform worse. Is that essentially?
Yes. Yeah. So they've done that by manipulating sleep tracker data. But the sort of the classic study that did this was the group at Harvard, which included Ellen Langer and Steve Lockley. And what they did is they took people into the lab. They had them sleep for 5 hours and 8 hours on different nights. And then half the individuals were randomized to have the clock time manipulated while they were asleep. So if you slept for 5 hours, or half of the people who slept for 5 hours were told that they slept for 8 hours, and half the people who slept for 8 hours were told that they slept for 5 hours. And then, some were lying, like slept for 5 hours, told they slept for 5 hours. What affected cognitive function the next day was perceived amount of sleep rather than the actual amount of sleep. So if you wake up in the morning and you check your wearable and it says, hey, you slept really badly last night, you will perform worse the next day, but it's because you think you'll perform worse rather than because you can't deal with that, with a night of poor sleep. And actually, I think we're pretty resilient. I wouldn't recommend it long term, but the odd night of bad sleep doesn't seem to have that much of an effect.
Short-term resilient is what you're saying, right?
Yeah,
so
short-term
resilience. You can't have a lot of days in a row of bad sleep, but your mind can handle one or two is kind of what I hear you say. Now, you mentioned neuroplasticity. Another area where I've heard a lot of claims, right? And the claim goes like this. Kids, you drop a kid in the middle of, pick a country, drop a 2, 3, 5-year-old, let's say, and they're going to learn that language really fast. You drop an adult there, they're going to learn it much slower. The claim being that kids have a greater capacity for neuroplasticity. So the question to you is, like, what is neuroplasticity, and does it decline with age?
So neuroplasticity is kind of, as I sort of briefly outlined, is essentially, is essentially this idea that we can make new connections and we can build up areas of the brain where there's increased need, increased demand. And there's plenty of evidence in adult humans to show that this is possible. I don't necessarily, we can't necessarily say we're getting more neurons in an area. We're probably not, but we can build up that area, improve the structure and function of it, and we can see that on things like an MRI scan. Part of that with neuroplasticity is deciding, which neurons are connected to which and in what way. Billions and billions of connections in the brain, and these are constantly being pruned or added. That's the process of neuroplasticity, and it continues throughout the entire life. So we don't lose the ability to learn or develop new skills or remember new things as we get older. We don't lose it entirely, but to an extent it does get harder, but there's a very good reason for that. So when you're a kid, your brain is essentially a sponge on purpose, right? So the parts of the brain that are most related to your most complex cognitive functions, part of the prefrontal cortex, parts of the temporal lobe, the parietal lobe, these are essentially completely undeveloped when we're born, and their function is entirely driven by the environment and how we engage with it. So that's why kids are constantly seeking out inputs to try and drive the development of these parts of the brain. That drives neuroplasticity, and then they need to sleep a ton afterwards in order to consolidate all of those processes. When you're an adult, you've spent decades adapting to the environment that you have. And so if your brain was just like super changeable, was like, hey, today I'm just going to do this and this, right? You're not going to be able to do the job that you have and those skills that you've crafted and learned. You're not going to be able to have those same social relationships because, you need some stability in the system, right? That's the whole process of learning and development. But that doesn't mean that you can't do it or that you shouldn't do it. And I would argue that you should, because by driving these processes, we also drive some of the kind of maintenance, anti-aging, process, for one of a sort of a broader term, processes in the brain. So one of the reasons why we talk about kids versus adults being dropped into, a country and learning the language the way we do is not necessarily that when you're older, you can't learn a new language. In general, when we're thinking about learning new skills as an adult, think about the time and the effort that you give to it compared to a kid who, you're right. So when I was a kid, I was dropped into schools in Germany and France, not speaking any German or French, with teachers and kids who didn't speak any English. It is like, have at it. It's time to go. You've got to figure it out. But if I'm 40 years old and I'm trying to learn Spanish, and I do that for 30 minutes, 2 or 3 times a week when I have a bit of time, right? The drive for learning and neuroplasticity is so different in those two scenarios. So a lot of what happens is that when we get older, we don't have as much time, we don't have as many cognitive resources to engage with these learning processes, and at the same time we think, well, I'm older, so I just can't do it. Then it becomes self-fulfilling.
Yeah, let me paint a picture for you that is very much on my mind when it comes to this distinction that you're talking about. When I was learning surfing, something caught my eye, which is, on a given sunset, I would watch these young Costa Rican kids, like, I don't know, 10, right? Just going out there on their shortboards and over and over and over again, sending it, falling, and doing it for hours, right? And doing, like, just taking risks, being unembarrassed is probably not a word, but being bold. And then I think about how I was doing it, which is I got my little hour here. I go out with the coach. I'm self-conscious. I don't want to fall the right way. I'm worried about what everybody else is thinking of me. And I also have a job. And so I'm like, I got to go back in and I'm got other things shaping my time. Whereas that kid's just out there trying over and over again. And I was thinking to myself, well, what can you draw from that? Like, most adults can't be like, all right, I'm not going to have a job. But I think what they can do is say, how do I provide depth in those moments, right? So avoid multitasking, right? So when you're doing the thing, do the thing. 2 is like try to shorten the feedback loops and rep cycles so that instead of just being like out there with your gear and like being cool, it's like just go, go, go. Like think about it like you used to do a kid when you used to shoot 50, threes in a row out in the basketball court. Don't overthink, just keep going, keep going. Either have somebody provide you that feedback so that you could, as you're redoing things, what you need to improve, or just be conscious of it. All right, I tried this thing, I fell. Let me try it again a different way, and maybe I won't fall, and do it 30 times in a row. I don't know. That's what it reminded me of. But yeah, are there sort of, are there tricks like that or ways of thinking about it? I know you've had some extensive conversations about the downsides of multitasking, right? And I guess multitasking in a way is related to this.
Yeah, and I think the 2 main tricks, and I mean you've essentially covered most of them. One is to be present and focused in the moment, right? Because particularly as we get older, neuroplasticity requires significant engagement with the process. You have to like tell your brain this is important. I need to learn this, and that requires a certain amount of arousal, right? So if we're just kind of trying it out and not feeling really into it, that's not going to provide the necessary signals. And then, of course, if we're trying to do something else at the same time, we're not fully engaged in the process. The other part of it, which you alluded to, but which I think is really important, is failure and risk taking. And there's a couple of reasons for that. One is that when you try something on your board and you wipe out, all of a sudden you're flooded with noradrenaline and all these other things that actually help to drive neuroplasticity. That there's that kind of that friction that we feel when we're not good at something. That is part of our brain saying, "Hey, there's something I need to get better at here." And actually, you can measure these signals in the brain when there's this mismatch between what you want to happen or what you think will happen and what actually happens. So trying things so that you're pushing at the edge of your capabilities and failing kind of sort of creates this signal in the brain that says, hey, there's something that we can learn here, as well as focusing your attention in on it. So being present, being engaged, being aroused enough, actually sort of taking part, and then making mistakes and pushing yourself so that you make mistakes. Those are the things that kind of speed up this process.
Now, let's talk about socialization here, like friends, right? Like, I've heard you talk a bit about this, but and Richard Reeves and I talked about this the other day, which is like, especially men, but people in general are making less friends. And the older you get, the less friends you make and keep.
Yeah.
How much does it matter that you're, who you spend time with and like the quality of those relationships and what you're doing with people around you?
A couple of years ago, a colleague of mine, Josh Turknet, we have a podcast together. He's a neurologist. We wrote this paper about demand-driven decline, basically saying that we think that a large part of cognitive decline as we get older is driven by the fact that we're not engaging in these processes that continue brain function. I then spoke to a friend of mine, Dr. Julian Abel, who's a retired palliative care physician in the UK. And his response was, this is right, but I'm sure it's all driven by social relationships and social connection. And the reason for that is almost all of the things that we do that really engage our brains require other people to be around. Like we talked about dancing. Dancing is fun when you're on your own, but you add other people, all of a sudden, right? Are you following? Are you leading? How are you connecting to that person? You get more of that like reaction to the environment, as well as the benefits of actually interacting with other humans. And we know from a lot of really interesting sort of physiological and immunological research that feeling lonely or socially isolated drives this sort of like stress and inflammatory response pathways, which are normal adaptive pathways that improve survival when we're isolated in the wilderness at some part in our species history. But over long periods of time, they then seem to contribute to cardiovascular disease, dementia, depression, a whole host of potential chronic diseases. And yes, feeling socially supported, having friends, living with somebody else, and actually it doesn't need to be a romantic partner, doesn't even necessarily need to be a human. There's some research that suggests pets can provide some of this benefit. And a lot of it, if you're thinking about what's actually driving this, is in those situations having opportunities for pro-social behavior. So doing something for somebody else seems to be, if you want to like look at the physiology, it like activates the vagus nerve, which has all these sort of anti-inflammatory and relaxing properties like throughout the body. But it's that process of engaging with and helping others that seems to have a bunch of really interesting physiological effects that then affect our health. So depending on your viewpoint, your social environment may be the most, if not the most, one of the most important factors, for our long-term, both physical and cognitive health.
So if I'm hearing you correctly, there's certain social aspects of just doing something with somebody else, and then there's like the so-called like helper's high. Like if you're like not just doing it with them, but you're actually helping them, that's even better. Is that what I hear you saying?
Yeah. So there have been some studies, and it's difficult to do a large randomized trial to kind of figure out how make somebody volunteer and help somebody else, right? Although there are some studies that show that taking older adults and randomizing some of them into a waitlist group and some of them into like a volunteering group, you see health and cognitive benefits in the volunteering group, and people who volunteer seem to have better health outcomes. But then there are other studies that have looked at within partnerships or within two people, if one is more the sort of the person who's taken care of, right, they feel socially connected, they feel supported, and the other person is the carer. The carer seems to get more health benefits than the caree. So there's some magic in helping and looking after somebody else or something else.
Yeah, it reminds me of my grandfather's wife, who is still alive. My grandfather died like a decade ago, and she that was her purpose in many ways. Towards the end, my grandfather was he really struggled, and she was there's so many different components of it. She was active. She had something, a mission every single day, whereas he was really in decline. And maybe that's a good place for us to just kind of end on an important subject here, which is retirement, right? You've spoken a lot about this. Retirement is a risk. I see it with my dad, who has kind of sort of retired and then unretired many times as a physician. And I see in him like this tug of war between feeling like he should retire because that's some kind of expectation, and then feeling bored and purposeless and then jumping back into it. We could stipulate to the fact that if you retire and you are not, you lose a sense of purpose or activity. Based on everything we've said, like it's pretty obvious the downsides of that. But how should people treat retirement based on that fact base?
Yeah, so you're right that there are now several large epidemiological studies that suggest that retirement is the point at which cognitive function starts to accelerate in that age range. Sort of once we get into our 60s, and in particular, the risk is greatest in people who retire early, and that's after accounting for like medical conditions and things that would make one retire early. And it's thought that this is because you're removing the main cognitive and often social stimuli that we get, right, from both the work that we do, particularly if it's complex work, like as a physician, and the social environment that work is done in. And we remove both of those when we retire, and that seems to increase the risk of cognitive decline. This seems to be part, and it's interesting because you mentioned that your dad kind of like went back to work. In the studies where they looked at people who retired and then went back to work, some of the negative effects of cognitive decline are reversed if you go back to work. So that kind of suggests that this really is there is something about the work environment that's stimulating the brain and providing some benefit there. But people have done their time. They've finished their career. They want to do something else. I'm not saying you should keep working until you drop dead, although that's always an option. So I think you just need to make sure that you're finding ways to replace the stimulus that you receive from work in your retirement period. And so it could be any of the things that you mentioned that you've done on your right. So maybe he starts his own yearly task. This is the skill that I'm going to learn this year, or these are the people I'm going to spend time with this year. I think if you continue to provide ongoing stimulus, both cognitive, physical, and social, then there's no reason why retirement should be a risk period.
Well, Tommy, that's a great place to end. Before I let you go, talk about your podcast and anything else that you're working on where folks can find your work and support it.
Yeah, thanks. So my podcast is called the Better Brain Fitness Podcast, which I host with Dr. Josh Turknett. We'll find that wherever you find podcasts. And then probably the easiest place, if people use social media, is Instagram at Dr. Tommy Wood. And I'll usually post other podcasts I've done, papers that I've written that people might find interesting. And as new projects come up, they'll be released on there.
All right, Tommy. Well, thank you so much, man.
Thanks so much for having me.
All right, everybody. Thank you for listening. Remember to rate, review, subscribe. Our voicemail is 321-200-0570. Our email is lostdebate@thebranchmedia.org. And again, go out there and get pre-order your copy of Garbage Town, my new novel. And if once you read it, go on Amazon, Goodreads, Storygraph, wherever, and leave a 5-star review. Thank you very much, everybody.